Good morning. We are going to look at how to take a quadratic equation in vertex form and change it into standard form, and then standard form, and then intercept form, which for those of you that may or may not remember, intercept form is actually what we call, or can be called, sometimes referred to as factored form. That's why we have been factoring so much, because when you take a quadratic and you put it into its factored form, then you know the intercepts. Woo! Okay, so the equation that they're giving us, of course, is not in either of these forms. The equation that they're giving us here is in vertex form. This was the very first form of a quadratic equation that we learned about. And so let's pull out that information that we know right now from it. We know that since it's in vertex form, we know the vertex point, which is then 1, negative 4. We can take that and go and put it in our list of critical points, or critical, essential values, essential points down here. The vertex is 1, negative 4. Is there anything else that I know in this list about this? Yes, of course. I know also then that the axis of symmetry is also x equals positive 1. And that's because that value 1 from the x coordinate of the vertex is the axis of symmetry. Now, I've said to you guys before, and I'm going to remind you, and that is that there's a lot of things that we're asked to do here, right? Take an equation, change to this form, change to that form, list all these essential points, and create the graph. There's nothing that says you have to do it in any certain order. So your best bet is to put stuff down in this list that you know as you get it, and also then put it on the graph as it comes. So I'm going to take a second right now to put these two pieces of information, axis of symmetry and vertex, on my graph. My axis of symmetry, of course, is going to be here at x equals positive 1. And then I'm going to have my vertex point at at 1, negative 4 right here. Okay, now that I've got those things written down and they are on my graph, I'm ready to convert to standard form. And, just to kind of real quick, what is standard form? It is this: ax squared plus bx plus c. This could be a 0. It could also be an f of x or a y, any of those things. This is my goal. So the way that I achieve this is actually quite simple. I take the binomial that's being squared here and I multiply it out. So if I work towards doing that, x minus 1 squared is really x minus 1 times x minus 1. Can't forget the 4, though, at the end. That's important. So minus 4. Okay, now my job is to start multiplying those two binomials. X times x is, of course, x squared. X times negative 1 is negative x. Negative 1 times x is negative x. Negative 1 times times negative 1. Negative 1 times negative 1 is positive 1. And then minus 4 at the end, can't forget it. It is important that you do not mess up the signs. This is probably the biggest place where people make mistakes. They go, so just be methodical. Go slow. Sometimes the best way to not make a mistake with that kind of stuff is say it to yourself. Like say it in your head, negative 1 times negative 1 is positive 1, or whatever. Or say it out loud. Who cares, right? Okay, my job at this point is to collect the like terms. So I only have one x squared term. I have two x terms though. Negative x minus 1 more x is minus 2 x's. And then 1 minus 4 is negative 3. And voila, this is my standard form. So this becomes f of x equals x squared minus 2x minus 3. In this situation, you can see it's in the same format as I had written here for you. And I know then that A is 1, B is -2, and C is -3. Fabulous. Is there anything in my list of critical points, critical values, that I know from the standard form? Yes, I know that when in quadratic equation is in standard form, that the C value is actually my y-intercept. So this guy, -3, is my y-intercept. And I can then write that in my list. Of course, it's a point. It has the coordinates 0, -3. And when I include it on my graph, it looks like this. Right there. Okay, now let's move on to changing this guy from standard form to factored form or intercept form. In order to do that, I just take this this x squared minus 2x minus 3 part, and I factor it. So if I'm doing that, I'm asking myself, this is a trinomial, right? So I have to find two factors that will multiply to -3, but add to -2. Now there's only two factors of -3 anyways, and that's going to be 3 and 1. In order to make their product negative, one of them has to be negative. In order to make their sum positive, negative, like -2, I have to have the larger value, 3, be negative. -3 plus 1 is -2. Since there is no number in front of the x squared, right here, there's the value of a is 1, then that means that I can jump straight to writing these as factors with x minus 3 times x plus 1. -3, positive 1. And this is my intercept form. Great thing about intercept form is that what? Oh, I immediately know the x-intercepts. Yay! From this one, I get x minus 3 equals 0, so x is equal to positive 3. From this one, I get x plus 1 equals 0, and so x is equal to -1. These are the solutions. The x-intercepts are written as points, right? Solutions. The x-intercepts are 3, 0, -1, 0. When I put those on my graph, they go right here and right here. And I've got a lot of nice makings of a parabola. The one more thing before I finish this off that I can do to help myself right now is I can reflect the y-intercept point across the axis of symmetry and get another point over there on the outside of the parabola. And now I'm ready to draw my parabola. Yay! This completes our example. Bye-bye.